Hello everyone. So we're going to discuss in this video about a DNDC model and its calibration. DNDC stands for denitrification and decomposition model. It's used for modeling greenhouse gas emissions from agricultural soils. And there are other parameters that you can model, including hydrology, yield, temperatures, etc. So here is the website. You can download it from this website. It's a Canadian version where I have created a calibration system for it, and this is a website where you can download calibration system from. You need just these two files, caln.py and run.bat, and you can save them in a folder somewhere. So next is I'm showing you this folder where I have almost a fresh install of DNDC. It basically is extracting all the files and then putting them in a folder DNDC in your C drive. And here I have created another folder called calibrator where I have these two files that I was talking about, caln.py and then run.bat. To run this, we have to take a few more steps before we actually run this calibration system. So I'm going to go back here, and you go into this folder called exe, and here the subdirectory is console. So in this console you have these files. You copy these files and bring them back to your DNDC root folder and paste them here, and then you replace them. So by default it comes as a GUI, which is a graphical user interface. So now we have created one that is we have provided one which is a CLI, command line interface. Here I'm unblocking it because of Microsoft security. We have to unblock it first. So if I just double click it, you will see this funny message. It just means that CLI is active. Now I can go back to my calibrator and I can run this run.bat. Again, I have to go through the security of Microsoft. Here it will check if you have Python installed on your system or not. If not, it will install. And there are certain supporting dependencies that it will automatically install if you don't have them installed already. In my case, they are already installed, so it will go ahead and open the system. And here is that calibration system. This is standalone user interface for calibration that will basically do calibration based on Bayesian optimization system. Here we have a few files that we provide to the system, and we need to basically create those files. So here you can see there is a drop down menu where it says yield, and you can select any parameter that you would like to calibrate for. In this case it's yield that's already selected, and these are some of the input files that you need to prepare. It will show me what this model is capable of calibrating. There can be other metrics that you can calibrate with it. Here you can just download a template to see how you have to put that information together in terms of, let's say, observed yield. So you want to know how that observed yield should be put together in your CSV, so that when its calibration is running, it can compare your modeled information with the observed information. So here I just selected a folder to save it in, and here I can just go to that folder and I have that template downloaded. Yeah, here is the template, and now you can see in one column I have year, and the other column I have the value, which is the yield value in kilogram hectare per year. Yeah, so this is basically how you have to prepare your file of observed. In case of NEE, it will be different. You will have a template, you just follow the template and you will be fine. In this case, I am demonstrating it with the default case that is already when you already in the system when you install it. This is Ottawa site, and I have already put together the yield for Ottawa case. So this is the observed yield that you can see. I can just close it now. The other file that was there, you will have a template for that as well. This is the parameter file. So basically everything in DNDC in terms of inputs is saved in a DND file, and all that input information in that is in that one file. So here we are just showing that what parameter I want to tweak and what should be its minimum, what should be its maximum bound, and what is the line number for it in the DND file, in the input file. So I'm going to show you how I basically do it. So this is a DND file. I just open that file and it has all the input information. I Control A, Control C, close it, and I create a separate Excel file. It's an intermediary step, so I just name it anything and I open it. Now I can paste it here, and now I can just say Control A, E. Basically, so basically here you can go into data, and then you basically have to give it a delimitation system, and it has a delimitation system of space. So you click that, space, next, finish. Once you do that, now it will separate that data into two columns where you have the parameter and its assigned value in the B column. And here I'm going to do is add a line number column so that I can know what line numbers everything is at. So I'm just going to scroll it down all the way. Now I have the line numbers. Now what I am preparing with this for is accumulated temperature or heat or pHu values. So I'm just going to apply a filter here, accumulated, and here it gives me that. So click OK. Now I have accumulated temperature for all different crops that are in there. So I'm just going to copy that and create a new sheet and just paste it here as values. That's it. So now I know my current values, and now I know my line number. So I just have to transfer this information into the other sheet, in the parameter sheet, and take it from there. So this is the parameter sheet. You see the line numbers, you see the parameter name, and the minimum and the maximum are basically something you have to decide based on your knowledge of different crops, and you add those information there and save it up. So these are the two files that you have to prepare. Of course, after creating all the input in first run of the DNDC, these are the two files that you need. After that, you can go back into the calibrator system. I'm just going to run it for yield right now, and here I can go same in the sites folder, Ottawa, and this is a batch file. It just contains basically the address to your DND file, which is in C drive sites Ottawa. So that's the address. It is required for the CLI system or command line interface to access that file. Here I am going to give it the actual DND file because that's what the calibrator needs to find the line numbers and change values as it goes along. Here I'm going to pick the observed information, or the yield in this case, and the last one is parameter CSV. So we can calibrate with any other parameters like respirations. Here I'm just going to give it one name, which is Ottawa_1. That's the name it will use to create a folder where it will save all the results. Here you can select any number of iterations that you would like. It depends on how many parameters you are calibrating with. In this case, there are several. So I'll probably go 250 or 200 for the demonstration purpose. I will leave it at 10. Save DND backup. So every iteration, it will save the DND file so that you can use it in the future, and it can also save the entire results for each run. It takes a lot of space. It can go into GBs, but if you want to save it for other analytics, you can, or you can toggle it off to save disk space. We can go ahead and click start calibration. Once we hit start calibration, it starts with a base run first, which is the first run with original values, and it will show you the results in this console where it will show you the RMSE and other associated metrics, and then it will start to tweak numbers, and you will see all that information kind of going up in this log as it moves along. So you can see information here. I already have a run system, so this is basically a folder. It will create on its own in this folder. You don't have to worry about it. You just go in this folder, and I have one run already done, which is this is auto one that is still running. This is the previous run I have, and I can show some results from here. So this is an Excel file that has all the results that are consolidated from each iteration. This is DND backup files from 0 to 10, 0 being the base, and then 10 other iterations. This is the folder where you have all the results of each iteration, all parameters. If you want to later on look at them, you can. And going back to that Excel file, this is Excel file. You have 4 sheets here. The first sheet is where you see all the values input, and it also highlights which one was the best iteration. In this case, it was number 6. And if you scroll towards your right, you will see the column with R-square values, RMSE values, and others. Then you have 3 other sheets. This is the best iteration data, basically coming from the first. It just isolates it. Here you have the data comparison between observed and best modeled iteration results, and you can see your results, yield results from here. And the last one has the iteration data. That means all the yield values from base to iteration 10 are all in here in these columns. And so you can see how each number looked like. You can do some sensitivity analysis through this. Also from the all iterations sheet in the first one, you can do the sensitivity analysis from there as well. So that's the entire calibration system. You can calibrate it at your hard content as much as you can to get your numbers as close to observed values as possible. And this definitely saves time and does things more systematically, reduces the number of runs, and computationally it's less expensive than actually running every single possibility within a range. So I hope this helps all the DNDC modelers out there. Thank you very much. Take care. Bye-bye.